Now the last one we are going to see the output of an LTI system in a live example. I have an audio file, and I'm going to it is going to have two channels. We are going to play the audio and see what is the first channel and second channel, and we are going to extract and see. Okay, see the example. I think the audio file is not there. Let me check. Is there ringtone? Just a second, I'll check whether the path is correctly given. I'll give the path. Whenever you are working with anything, the path should be correct. Otherwise, MATLAB will not pick the file correctly. I think you heard sound, right? So first one, see, I am reading the audio file. That is done. Now I am playing the sound. So you heard the first sound, that is I am playing the sound. Next, what I am doing, I am reading this waveform again. I am displaying the size. I am playing it again. Okay. This sound has two channels. I am going to extract H1 and H2. H1 is the first channel, H2 is the second channel. So now I'm going to type, I'm going to convolve and see. So why, whenever you have the input, you will be convolving with the impulse response to get the output, right? So y1 and y2 values I differ, and I give y1, y is equal to y1, y2. And I give the sound source code. When I run this code, are able to hear? It's running again and again. Okay, so you are able to hear convolution. Two channels are there. You are able to hear two different sounds, right? So one is the total input sound. You see, the first one is the input. First one has two different channels, and third one is combination of both. And the last one you get by applying convolution. So you can even apply to your own audio files. You can upload it in MATLAB, and you can even do. This is one real-time example of how we are doing convolution with an audio signal. So far we have done theoretically using triangular pulse and rectangular pulse, right? So when you do convolution using the live audio signal, you will be able to understand things better. Now, last one is we have how to find the impulse response for an LTI system. So that is given, a signal is given, and you can choose the say input sync of n, and they are plotting the input and output. Can give this y to be the output. Okay, here both the input and output are going to be exactly same. So you can plot the x, and x is going to be the input and y is going to be the output. So I can give the plot for x and y, same thing. So y, if I give y is equal to e power n, exponential of n, we'll try giving y is equal to e power n. You run that, and get the value of n. Okay, that is how an LTI system is visualized using MATLAB. Okay, this is one example I wanted you to show.